Alright, so this is part 2 of me wasting both our times by working this study guide out in excruciating detail. I'm going to start with 16A, which is where I left off. It has to do with momentum. So it says, what is the momentum of a compact car with a mass of 912 kilograms if it moves at a velocity of 17 meters per second? So we're given a mass, 912, a velocity of 17. Momentum is lowercase p, as confusing as that is. So lowercase p equals m times v. 912 times 17. And we're going to get that the momentum is 15,504. Momentum does not have its own units, it just takes the units of these, so it's kilogram meters per second. Yay! Alright, turning over, we've got some more difficult momentum problems over here. This says a 4,900 kilogram freight truck accelerates from 3.6 to 8.1 meters per second in 22 seconds by applying a constant force. What is the magnitude of the force? Alright, for this one I'm going to dig out my formula sheet, which is apparently easier said than done. Alright, so we have a relationship that change in momentum is m delta v, and change in momentum is also force delta t. So we can just set these two equal to each other and get an equation that says mass times the change in velocity equals force times the change in time. So our mass is 4,900. Our change in velocity is 8.1 minus 3.6. We're looking for the force, and our change in time is 22 seconds. So this ends up being 49,000 times 4.5 equals 22F. And our final answer is going to be that F is 1002.3 newtons. And just in case you're wondering that, you multiply these and then divide by 22F. Alright, this next one, a baseball player exerts a force of 125 newtons on a 0.18 kilogram baseball for 0.33 seconds. What is the baseball's change in momentum? This is sort of a trick question because you actually don't need to know this to solve it. Change in momentum from up here is F delta t. So all you have to do is 125 times 0.33 and you get 41.25 kilogram meters per second. Alright, these next two problems also have to do with momentum, but they are collision problems, which makes them a little more difficult. So, here we're told that a 7,200 kilogram freight car collides with a stationary 8,300 kilogram freight car. If the cars become stuck together and move off with a velocity of 2.4, how fast was the 7,200 kilogram car moving before the collision. So, because they stuck together, this is inelastic, which means we're going to use the formula M1 V1 initial plus M2 V2 initial equals M1 plus M2 V final. Now, you may notice that they didn't give us V2I, but they actually did. It's stationary, so V2I is 0. So now we can just start plugging things in. We're going to have 7,200 times V1I, which is what we're solving for, plus this whole term becomes 0, equals 7,200 plus 8,300 times 2.4. So that's going to be 7,200 V1I equals 15,500 times 2.4. 72 V1I equals 37,200. And then V1I is going to end up equaling 5.17 meters per second. This answer should make sense because it's going faster at the beginning than it ends up at the end, which is pretty logical because hitting the stationary car is going to slow it down. Okay, this one. A 2450 kilogram vehicle moving at 36 meters per second rolls into a stationary 1775 kilogram vehicle. Again, stationary tells us that V2I is 0. If the first vehicle comes to a complete stop after the collision, how fast does the second vehicle move after the collision? So one's coming to a stop and one's continuing to move, so that means that it is definitely elastic, which means we're going to use M1 V1I plus M2 V2I equals M1 V1 final plus M2 V2 final. So we're going to have 2460 times 3.6. Oh, my lights just turned off. Sorry about that. Okay, so we have 4260 times 3.6 plus this whole term is 0 equals, now V1 final is 0, it comes to a complete stop, so this term is 0 plus 1775 times V2F, which is what we're solving for. So this comes out to 8820 equals 1775 V2F. Divide both sides by 1775, and V2F comes out to 4.97 meters per second. The county formula sheet gives you the versions. It labels them elastic and inelastic, so you don't even have to remember which formula goes with which, but you do need to be able to identify from the problem whether it's elastic or inelastic. Moving on. All right. Again, I'm going to go through this pretty fast. Explain the effects of force and distance on determining torque. in a system in equilibrium. So there are three things that affect torque. Amount of force, direction of force, and the length of the lever arm. When you're talking about things in equilibrium, the torque on each side must be equal, which is represented by F1 D1 equals F2 D2. So heavier objects need to be closer to the center, whereas lighter objects need to be further from the center to reach equilibrium. All right, the nature of electric charge. There are three types of charged particles: protons, which are positive, electrons, which are negative, and neutrons, which are neutral. The other big points are that likes repel and opposites attract. Alright, so down here, demonstrate understanding of the proportional relationship between electric charge, distance, and electric force. So, all of these are going to use this formula for electric force, K Q1 Q2 over D squared, and you're going to use the law of ones. So for this first one, if one charge doubles, we'll have 1 for K, 2 for one of the charges, 1 for the other charge, and 1 for D. So if one charge doubles, your answer doubles. If one charge triples, just by looking at this, you should be able to tell that that's going to mean that the charge triples. Now, what happens if the distance is tripled? We'll have 1, 1, 1 in the numerator, 3 squared in the denominator, so that's 1/9. If the distance tripled, the force goes down by 1/9. Now, one charge triples and the distance doubles. That's going to be 3 over 4. Distance is reduced by 1/2. Here is where a lot of people make mistakes. They look at this 1 over 1/4 and they say, oh, that's 1/4. Remember how dividing fractions work. You multiply by the reciprocal. So you do 1 times the reciprocal of 1/4 is 4 over 1. So 1 over 1/4 is 4, not 1/4. Moving right along. All right. Circuit diagrams. It says to identify whether it's series or parallel, and then calculate the current, voltages, and resistances for each resistor, as well as the total current, voltage, and resistance for the circuit. Let's go through and just identify them first. This one has 2 paths the current can possibly take, which means that it's parallel. This one only has 1 path, so it's series, 1 path, series, two paths parallel. Now I'm going to make some charts. V, I, R. Here we only have two resistors, so we'll have V1, V2, and V total, I1, I2, and I total, R1, R2, and R total. Now on the formula sheet, it even helps you out some by telling you what stays constant for each type. In parallel, it's the voltage that stays constant. So we're given VT, which is 40. Since it's a constant, that means that V2 is 40 and V1 is 40. So they gave us one of our resistors, R1, which is 10, and they gave us one of our currents, which is actually, because both of the paths have to go through this point, that's I total is 5. So we're going to use the fact that V equals I times R, I equals V over R, and R equals V over I. So I equals V over R, 40 divided by 10 is 4. In a parallel circuit, the currents have to add up, so I2 must be 1. Then we can use R equals V over I. 40 divided by 1 is 40. And then R total, 40 divided by 5 is 8. All right, let's look at this one over here. I'm going to make my chart a little bigger this time. Now we have 3 resistors, so we're going to have V1, V2, V3, V total, I1, I2, I3, I total, R1, R2, R3, R total. All right, well, they give us one current, and for a series circuit, the current is always the same. So we can just put that 2 in every space on here. They also give us all 3 resistances, 20, 60, 30. For a series circuit, you can just add up resistances. So that's going to be 80 plus 30 is 110. Now we can just use the V equals I times R to fill in these. 2 times 20 is 40, 2 times 60 is 120, 2 times 30 is 60, and 2 times 110 equals 220. If we wanted to check our work, 40 plus 60 plus 120 does in fact equal 220, so we can be reasonably sure that we did all of that right. Now we have another series circuit, so we're just going to do the same kinds of stuff again. While I'm thinking about it, again, this is on the formula sheet, but I probably should have written this down before I started working these. For series circuits, V adds up, I stays the same, and resistance adds up. For parallel, voltage stays the same, current adds up, And resistance has this funny formula where you have to use reciprocals and stuff. But again, these are given to you on the formula sheet. You don't even have to remember them for yourself. V, I, R. All right, what have they given us? They've given us V total, which is 60. They've given us R1, which is 6. R2 is 10. R3 is 14. Again, for series circuit, they just add up. So 10, 16, 14 plus 6 is 20, plus 10 is 30. To get I, we're going to do V over R. 30 divided by 60 is 2. Current is always the same, so all of these are 2. Then we can find V just by multiplying. 2 times 6 is 12. 2 times 10 is 20. 2 times 14 is 28. And V1 plus V2 plus V3 does in fact add up to 60. Yay! Alright. This last one is a second parallel one. V1, V2, V total, I1, I2, I total, R1, R2, R total. They've given us V total, which is 24. Since it's a parallel circuit, all the voltages are the same. So 24, 24, 24. Then they've given us these resistances, 12 and 24. So we're going to divide to find the current. 24 divided by 12 is 2. 24 divided by 24 is 1. The current adds up. So 2 plus 1 is 3. Our total is going to be 24 divided by 3, which is 8. Yay! All right. I think we're done with the math, so I'm just going to try to go through these next few pretty fast. 22E, discuss the variables that influence the strength of a magnetic field around an electromagnet, i.e. the number of turns, the strength, and the presence or absence of a core. So the standard actually gives you all the three things. Number of loops, strength, I'm going to use the word amount of current. And presence, wow. Of iron core. So what you need to be able to do is tell me whether they're going to increase or increase things. More loops equals stronger magnet. Amount of current, more current, equals stronger magnet. And if the iron core is present, stronger magnet. That's pretty simple, right? Totally. All right, last page. Describe waves as a means of transporting energy. Remember that waves do not transport matter, just energy. The way they do this, they transport energy by disturbing the medium. And the amplitude of the wave tells you the amounts of energy transferred. The larger the amplitude, the more energy you're transferring. Compare and contrast mechanical and electromagnetic waves. Mechanical waves need a medium. They can be transverse or longitudinal. And the amplitude corresponds with the amount of energy. For EM waves, they do not need a medium. They're all transverse. And it's their frequency that tells you how much energy they have. All right, explain the relationship between wavelength, frequency, and wave speed. It's pretty simple. You have this formula. Wave speed equals wavelength times frequency. So looking at this formula, in a given medium, the velocity is a constant. So as, say, wavelength goes up, frequency must go down. So they are inversely related. Also, if frequency goes up, then wavelength must go down. So that's that relationship. And again, in a given medium, the wave speed is a constant. If it changes mediums, its speed will change, but only then. All right, this is the cruelest question on the whole test, or on the whole review, because we have not gotten to this yet, and we're not supposed to have gotten to it yet. So I'm just going to give you guys a brief overview. There are 3 different types of radiation that occur. Alpha, beta, and gamma. Some key points from each. An alpha decay releases a helium nucleus, which we call an alpha particle. Which means that it has a positive charge and they're pretty slow. They can be stopped by paper. So even if you are exposed to something that is emitting alpha radiation, you're not in much danger because it's not going to be able to make it through your clothes. Beta decay occurs when a neutron spits out an electron and becomes a proton. The electron is what we refer to as the beta particle. It has a negative charge. It can be stopped by aluminum. I can never spell aluminum. Then last but not least, we have gamma radiation. Gamma radiation emits photons, which are EM radiation. It has no charge and no mass. High energy, hard to stop. As in, you would need several feet of concrete or lead.